All right, so we're looking at trig equations today. So whenever you find an unknown angle in a triangle, you're solving a trig equation. So, for example, if you've got cos x equals 0.34, we can use our calculator and we would do x is equal to cos -1 of 0.34. And you can use your calculator for that. But now that we know how to find the trig ratios of angles of any magnitude, so greater than 90 degrees, there can be more than one solution. So we have to think about what the domain is that we're given. So always pay careful attention to what the domain is and think about where the angle can lie. And then we've looked at this notation before, so sine squared x is the same as sine x squared. So we also start thinking about our exact ratios, okay, so our exact triangles. So you should have your reference sheet out in front of you, open to the trig section. So you've got your triangles and you've also got your cos squared x plus sine squared x is equal to 1. So that very bottom trig identity that we looked at as well. Okay, so if we want to solve cos x is equal to √3/2 in the domain 0 is less than or equal to x is less than or equal to 360. So cos is positive. So because it's positive, we know that it's going to be in the first quadrant, which is where it's equal to theta, and in the fourth quadrant, where it's 360 minus theta. This is one of our special triangles. So √3/2 is one of our special triangles. So we think about which one it is, and it's the second one. So it's the 1, 2, √3. Okay, and we're looking at when is cos going to be √3/2. So essentially, we want the √3 to be the adjacent side. So we're going to be looking at this top angle up here, which from our reference sheet is 30 degrees. Okay, so in the first quadrant, and the notation I think that there's sort of missing in here is that x is equal to cos -1 of √3/2. So x is equal to 30. Okay. In the fourth quadrant, x is going to be equal to, that's a 2, not a 7. In the fourth quadrant, x is equal to 360 minus that 30 degrees, so it's 330 degrees. Okay, so if we've got a second one, so if we have a look at this second example, so 2 sine squared x minus 1 is equal to 0. So that means what we can do is we can add 1 to both sides of the equation. So then we'd have 2 sine squared x is equal to 1, and then divide by 2. So sine squared x is equal to 1/2. So then we're thinking, okay, what triangle do I need to make sure that I've got 1/2? And we're going to be looking at that same triangle again. So it's going to be the 1, 2, √3. And we want opposite to be 1, so it's going to be this angle up here. So the opposite is 1 and our hypotenuse is 2, which again is our 30-degree angle. Now it's positive, so it has to be in the... Oh, no, sorry. Sine squared x is equal to... So here we've got sine squared x is equal to 1/2. We need to get just sine x. So what we have to do is take the square root. So when we take the square root of both sides, we end up with sine x is equal to plus or minus, because we've taken that square root, of 1/√2. So that means that it can be in all 4 quadrants, okay, because it can be a positive or a minus answer. Then we're thinking about our triangle, which is our 1/√2, not the triangle that I put there at all. Hey? Yeah, exactly. So we're going to need the 1/√2 triangle, which means our angle is going to be 45 degrees. Okay, so our answer in the first quadrant will be x is equal to 4. In the second, and then in the next quadrants, we're going to... Hang on, that's not 4. 1/√2 is 45 degrees. So x equals 45. Does your book say 4 or 45? Yeah. should say 45. So x is equal to 45. So our answers in other quadrants, x is equal to 180 minus 45, 180 plus 45, and then the 360 minus 45. They should really here have said, therefore, x equals 45, 135, 225, 315. Sort of list all four of them. All right, the third example, so solve tan x is equal to negative root 3. So we need tan to be negative. So this time we're going to end up in the second and fourth quadrants for tan. So if our answer is in the first quadrant, we still work that one out first because it gives us our acute angle that we're dealing with. So tan x would be equal to root 3, which, don't forget, is equivalent to root 3 over 1. So then you can use your 1, 2, root 3 triangle. Yep, so draw your triangle if you need to. You do have it on your reference sheet. 1, 2, root 3. And we want opposite over adjacent. So it's going to be root 3. So we're looking at this angle here, which is our 60-degree angle. So that's where x equals 60. So then our answers are x is equal to 180 minus 60 and 360 minus 60. Okay, for the next one. So one thing that's different with this one is that the angle is 2x, but our domain is only for x. All right, so what we are going to need to do is multiply all parts of the inequality. So 0 is going to be less than 2x, is going to be less than 720. So what I've done is I've times each part of that inequality by 2. Does that make sense? Yeah? Okay. So that means that our domain that we're looking for is now between 0 and 720. 2 sine 2x minus 1 is equal to 0. So sine 2x is equal to a half. So add the 1 to both sides, divide by 2. Yep? Okay. So now we know that sine 2x is equal to a half. It's positive. So it's going to be in the first and second quadrants. Then we can think about what's our angle that, so 1 and 2, we're going to be looking at our, once again, our 1, 2, root 3 triangle. And we want sine, so we want opposite over hypotenuse. So it's this angle, which is our 30 degrees. Okay, so 2 lots of x then is equal to 30 degrees, 180 minus 30, which gives us our 150, 360 plus 30. Okay, so that's where the 390 comes from. And then over here, so you could do it as 360 plus 180 minus your angle. Does that make sense? So you've gone the whole way around, 360 degrees. You go to another 180 and minus the angle, and that will give you your 510. Now, so far, we've still only found what 2 lots of x is equal to. So then you divide everything by 2 to find the values of x, the value of x. Okay, so the angle is 2x, but then we're finding the value of x. Everyone good with that? So solve cos x is equal to a half for 0 is less than x is less than 360. All right, so first of all, think what triangle do I need? And I'm going to need my, for 1 and 2, it's going to be the 1, 2, root 3 triangle. We want cos to be a half, so we want this angle here, which is 60 degrees. Okay, now also think what quadrants it's going to be in. Okay, so it's positive for cos, so we need the first quadrant and the fourth quadrant. So then we can say cos x is equal to a half. Okay, so x is equal to the cos negative 1 of a half, which is equal to 60. Because we're finding an angle, we think about that cos negative 1. So then x is also equal to 360 minus 60 in that fourth quadrant, which is equal to 300. So we can say, therefore, x equals 60 and 300, or 300 degrees. Okay, for the second one, we've got tan x is equal to -1. So first, this one, think if we've got a negative and we're in tan, which quadrants are we going to be in? We're going to be in the second and the fourth. That's where it's going to be negative. Which triangle are we going to use? 1, 1, root 2, yep. Okay, so we're using this triangle, which has 45-degree angles. Okay, so then we know, I'm just going to put a line here. So tan x is equal to -1, which is -1/1. So x equals tan -1, which is equal to, hang on, I'm just trying to think how to explain this. Yes. Yep. Okay, so I'm just thinking about how to work this out because we've sort of got to say in the first quadrant. So we probably should have put in here, in first quadrant, tan 1 is equal to 45 degrees. Sorry? Is that what, sorry?
Between those lines of working.
Yeah, yeah. So in the first quadrant, tan 1 is equal to 45 degrees. So then x is equal to, so then back here, x is equal to, no, I don't know that we need this line of working. Sorry. So tan x is equal to -1, which is equal to, we're 45 degrees. So in the second and fourth quadrants, that's better, sorry. Quadrant, x is going to equal 180 minus 45 and 180, oh sorry, not 180, 360 minus 45, which is going to equal 135 degrees and 315 degrees.
Miss,
Yep.
how do you know which quadrant it is for like sine 10?
Okay, so see, all stations to central. So this is something you might need to catch up. So we did a whole lesson on it, but you've got 4 quadrants, right?
Yeah.
And in the first quadrant, all ratios are positive.
Okay.
In the second quadrant, only sine is positive.
Also, STC when sine 10 comes.
Yeah, T is the tan quadrant is positive,
Yeah.
and C is the cos is positive.
Oh,
It's
okay.
like a tan, and then
Yeah.
it goes in a tan, and then you know.
Oh, and then it's just the ratios that you use.
Yeah, yeah.
Oh, okay, yeah.
Okay, so that's going to tell you which ones are positive. All right, so this time we've got sine 2x is equal to 1. So for 0s to 360. All right, so here, if we divide by 2, sine 2x is equal to 1/2. Everyone happy with that? Everyone happy with how I got that?
Yeah.
Yeah. Okay. Are we going to have positive answers or negative? Which quadrants are we going to be in?
First two.
Yep, the first 2, because we've got a positive answer. So it's in the first and second. So let's go over here now. So sine 2x is equal to 1/2. That means that 2x is equal to, and you can think about your triangle. So for 1/2, we're going to use the 1, 2, root 3, and we want this angle up here, which is 30 degrees. So 2x is equal to 30 degrees. And then we want, Okay, because we've got 2x, think about your domain. So our domain is 0 is less than or equal to x is less than or equal to 360. Now we need to make this 2x, so now our domain is going to become 0 is less than or equal to 2x is less than or equal to 720. So we're actually going to end up with 4 values. Because we're in 2 quadrants, we've doubled our domain, we're going to end up with 4 angles. Okay, so 2x is equal to 30. It's also equal to 180 minus 30, which is 150. It's also equal to 360 plus 30, so 390. And it's also equal to 540 minus 30, which will be 510. That's what 2x is equal to. Now we need to say what x is equal to, which will be 15 degrees, 75 degrees, half of 390 is 195 degrees, and 255 degrees. Okay. All right, question 4 is a bit different. So we've got solve sine x equals 0. Have we got a special triangle to give us 0? No, we don't. So what other thing have we got that we can use for trig? If we can't think about special triangles. Hey? No, Pythagoras isn't going to help us either. Hey? What about
the graph thingy.
our sine graph? Okay, so here's our sine graph. Okay, so remember we looked at that. So sine x equals 0 is what we're trying to solve. So we can say that x is equal to, when is x equal to 0? So it's equal to 0 here. So what's the, yep. So there, and there. What are those values? What angles would they be?
0, 90, 180.
180, 360. So remember that a sine graph does a normal sine graph does a complete thing in 360 degrees. So that means that halfway is 180 degrees. Your top up here would be 90 and your bottom would be 270. Okay, that's our answer. That's when sine x is equal to 0. Okay? Easy?
What if it wasn't sine?
What if it was cos?
Yeah.
Then you'd use the cos graph. So if it was cos, you'd use your cos graph, which starts at 1 and goes like this. Right? So it would be equal to 0 at 90 and 270. Yeah, that's cos. Tan's a bit different because, yeah, because tan's odd. Yeah. Okay, so example 5. So solve sec x is equal to 0.7, and we've got a different domain here as well. Okay, what is sec x?
Cos x.
1 over cos x. So 1 over cos x, whoops, is equal to 0.7. What's another way to write 0.7? We don't tend to deal with decimals much with trig.
0.70.
Right, what is cos? What's the cos ratio? Adjacent over hypotenuse. So if we write it as a fraction, so 1 over cos x is equal to 7 over 10. Yeah? Same thing. It'll still work if you do 70 over 100. What do you think I might do next to solve this?
Butterfly.
Oof, close. Just flip them both. We don't really want cos on the bottom, so let's just flip them both. So then we get, yep, cos x is equal to 10 over 7. Put it into your calculator. So x is equal to cos negative 1, 10 over 7. Because now that we've got numbers, we can put it into the calculator. What do you get? So cos -1, or second function cos, 10 over 7.
Math error.
Math error?
Yeah.
Okay.
Error. Does not
What is the trick? So if I wanted to find, if I had a triangle, a right-angled triangle, and I knew my side lengths and I wanted to find this angle down here, what two sides do I need for cos? Hypotenuse and which order do they go in? Okay, so this is my adjacent, this is my hypotenuse. What can you tell me about the hypotenuse in a triangle? Has to be the longest. So can I have my adjacent side longer than my hypotenuse? No. So there's actually no solution to this. It's not actually possible.
So
Okay.
just say no solution.
Yeah, so you would just say, once you get to the point where you've got cos 10 over 7, you can then say no solution.
Every time I get stuck in an exam, no solution.
Just see what happens.
You're right.
So we want to solve sine x minus 250 is equal to root 3 on 2. So what we can say now is that x minus 250 is equal to sine -1 of root 3 on 2. So sine root 3 on 2 is equal to what angle? So then we think about our triangle. Okay, and we're going to need the 1, 2, root 3. We want sine, so we want this angle here, which is 60 degrees.
That's the
Okay, so then x minus 250 is equal to either 60 degrees or we need to think about, so we wanted, so it was positive, so we need the first and second quadrants. So it can be equal to 60 or it can be equal to 120. Everyone happy with that part? Okay, now we haven't actually solved for x yet because so far we've got x minus 250. So then we can say x minus 250 equals 60, so x equals 310, or x minus 250 is equal to 120, so x equals 370. Now, what can you tell me about that 370?
It's above 360.
It is above 360. What's my domain? 360, so it's outside my domain. However, is there another angle that we could actually have there?
310.
Sorry?
310.
How'd you get 310?
I have no idea. I'm straight off the board.
Hey?
I'm straight off the board.
Well, no, we've got our 310, but we've already got that one. But this 370, have a think, with 370 degrees, right, we've gone all the way around and we've gone to here. Yeah. So what we're actually got is we've actually got, it's kind of like there's another angle up here, which there's a couple of ways to do it. I can visualise to myself that 370 is going to be x is equal to 10 degrees. Okay, it's within the domain. But you could also do it as 120 degrees. We could go back the other way, which would be minus 360. Sorry. Which would be negative 240. Right? And then if you do the negative 240 plus 250, you'll get your 10.
Yeah, I'll just stick with the...
I confused you there. So here, we can go back the other way. Right? Because if you're starting to say, oh, that's going to be outside my domain.
Once you hit 360, you just start going back.
So x minus 250 is equal to negative 240. X equals 10. When I add the 250 to both sides. Okay?
Yeah, the other one was easier.
Well, yeah, but it doesn't always work for you. But anyway, we can have a think about it. All right. Solve sine x plus root 3 cos x is equal to 0. So at the moment, we've got sine and cos. We really need to have one type of ratio to be able to solve it. So we need to put it all into sine, cos, or tan, but all into one. How do you think we can manipulate this so that we can get it all with one ratio. Give you a hint, I can maybe divide them all by something.
Cos.
Oh, that's what we did yesterday.
Okay, so if we divide them all by cos, we're going to have sine x over cos x plus root 3 cos x over cos x is equal to 0. So sine x over cos x is equal to tan x. So we can now say tan x plus root 3 is equal to 0 because cos x divided by cos x is 1. So then tan x is equal to negative root 3. Oh my goodness, all of a sudden we've got one of our exact triangles. So we're going to be it's a negative. So where is tan negative? Well, that's going to be in the second and fourth quadrants. Okay, so we're going to be looking at those two. We're going to think about the triangle we need, which is our root 3. So 1, 2, root 3. So we need opposite over adjacent. We need the opposite to be root 3. So we want our 60-degree angle. Okay. Everyone happy with that so far? Okay, so tan x equals negative 3. X equals, you can put your negative out the front really, root 3, so that was equal to, x is equal to 60. Okay, then think about our 2, so x will equal 180 minus 60, 360 minus 60. So x will equal 120 degrees or 300 degrees, and that's both within our domain, so that's fine. Okay, question 8. Let me know if I'm moving too fast or anything. Nope, go back. Okay, so question 8. Solve 2 sine squared x minus 3 sine x minus 2 equals 0. What sort of equation have we got? It is a long one. Hey? A lot of numbers? What's the highest power? 2. So if your highest power is a 2, what sort of equation have you got?
Square root.
Quadratic?
Quadratic.
Okay.
All by myself.
Yeah. So we're going to start pulling in some of our quadratic equation stuff as well. All right. So we've identified that we've got a quadratic. We've actually got 3 terms here as well. So we're actually going to have a quadratic trinomial. What we're going to do is we're going to let sine x be equal to something. Okay, so let's use the letter m equal sine x. If m is equal to sine x, our equation now becomes 2m squared minus 3m minus 2 is equal to 0. Hey? Yeah. Now we have to factorise it so we can solve it. Okay, now we haven't got 1 as a coefficient of m squared, so we'll try factorising using our 2 brackets over 2, okay, because I've multiplied by 2 too many, right, because 2m times 2m would actually give me 4m squared, so I need to make sure I divide that by 2. Okay, now we need to find 2 numbers that are going to multiply to give me negative 4, because 2 times negative 2, the constant term, and add to give me negative 3. Are there some nice numbers that will do that?
4 and
Negative 4 plus 1. So 2m minus 4, 2m plus 1. So now we've got a common factor that we can divide by. So what I'm doing is I'm dividing this by 2 and this by 2 with that 2 on the bottom. If you need to, you can factorise that bracket, so bring the common factor of 2 out the front of that bracket and then just cancel it from there. But if you can identify it within it, just make sure you cancel it from both. So then m minus 2, 2m plus 1 is equal to 0. So m minus 2 equals 0, or 2m plus 1 equals 0, which means m equals 2, or m equals negative a half. So take away the 1 from both sides, divide by 2. Have I solved the equation?
Hopefully.
No.
Unfortunately not.
We've found out what m is equal to, but what's m actually equal to? Sine x. Okay. So then we can say, I'd probably make another, so m is equal to sine x, so sine x equals 2, or sine x equals negative 1/2. Can sine x equal 2? Think about your graph. No, it never goes above 1. All right, so remember our sine graph, it never goes above 1. So for this one, we've got no solution. So then our sine x equals negative a half. We're going to have, so this is for the negative a half part. Where is sine negative? We're going to be looking in the third and fourth quadrants. Okay, so then we can say, and then a half, think about our triangle. So we want the 1 to root 3, and we want 1 to be opposite, so we're looking at this angle, which is 30 degrees. So we're looking at x is going to be equal to 180 plus 30, which is equal to 210, or x is going to be equal to 360 minus 30, which is 330. So I'm just going to put it, therefore x equals 210 degrees, 330 degrees. So this question, express 5 cot squared x minus 2 cosec x plus 2 in terms of cosec x, and hence, so using that result, solve the equation, blah, blah, blah. So we've got 2 verbs. We need to express something and we need to solve something. So we've got 2 things we're going to do. So I'm just going to rewrite the equation to begin with. So 5 cot squared x minus 2 cosec x plus 2. So that's my expression to begin with. And we want to change it so that it's in terms of cosec x. Okay, for this you need to think back to your trig identities. So your trig identities, we've got one on the reference sheet that you can rearrange, or if you look back to the lesson we did the other day, the trig identities one, we have one there which is, I'm just making sure I'm getting the right one for you guys. So cot squared x plus 1 is equal to cosec squared. So it's the very last one. So it was on page 14 of the trig section, the very last example. Okay, so I'm just going to write that here. So we've got cot squared, it says theta, but I'm going to use x, plus 1 is equal to cosec squared theta. Okay, so that means that I can replace cot squared x with cosec squared minus 1. Okay, because I would need to take away 1 from this side, take away 1 from this side to make it equal cot squared x. All right? Everyone happy with that? Hey? Oh, that should be, yeah, I did x. Yeah, no, that's okay. Okay, so now I'm going to replace my cot squared x with what we've just said cot squared x is equal to. So 5 cosec squared x minus 1 minus 2 cosec x plus 2. Expand the brackets, because then we'll get 5 cosec squared x minus 5 minus 2 cosec x plus 2, and simplify. So 5 cosec squared x minus 2 cosec x minus 3, because negative 5 plus 2. Okay, now we've got a quadratic again. Okay, but we've done as much as we needed to do. That's the express part. That's part A, if you want to think of it that way. Now we need to solve the equation 5 cot squared x minus 2 cosec x plus 2 equals 0. So we're going to keep it in this format that we've got. So we're going to now pick a pronumeral. P? Or did someone say L? I don't like L's. It looks too much like a 1. So we're going to let P equal cosec x. Okay. So now we've got 5p squared, so 5 cosec squared, minus 2p minus 3 is going to equal 0.
So much nicer.
I know. Okay, now we can factorise. So we're going to try for our 2 brackets again. Try this way because it is the quickest way to do it. Okay, so we're going to put 5p over 5. So we're looking for 2 numbers that are going to multiply to negative 15 and add to negative 2. I had a moment there. So negative 5 plus 3. So 5p minus 5, 5p plus 3. I can divide by, so I'm bringing my 5 out the front essentially and dividing by 5. So we're now left with p minus 1, 5p plus 3 is equal to 0. All right, haven't finished yet. Okay, so therefore p minus 1 equals 0, or 5p plus 3 equals 0. So p equals 1, or p equals negative 3 over 5. So I've taken away the 3 and divided by 5. All right, so therefore, because remember we let p equal cosec x, so now we can say cosec x equals 1, or cosec x equals negative 3 over 5. All right, what is cosec x? Sine. Okay, so 1 over sine x equals 1. Okay, so sine x equals 1, or 1 over sine x equals negative 5 on 3.
Negative 3.
No, because
Oh, no,
Yep. So I had to take the reciprocal. Okay, so I took the reciprocal of cosec, so I've got to take the reciprocal of the fraction. Is that possible?
no.
Because it's less than 1. Okay, so it's outside of the range of our sine graph, so this is no solution. Okay, when does, then think to our graph, sine graph, when does x equal 1? So what we're thinking is, whoops,
Be the 1.
so it's this 1 value here is where it's equal to 1. So it's 90 degrees, so x equals 90 degrees. But your calculators don't do cot squared or cosec x, so you have to be able to do those manipulations and things like that and think about it all. So what I advise you to do is to try and have a go at a couple of questions over the long weekend, okay? And definitely update your learning logs with a couple of questions as well. And then you've got whatever our next lesson is to do those questions in 5H. Okay, but get a few of them done for homework because you will forget it otherwise over the weekend.